I'm Mark Madsen, and I'm here to talk about data science and evolving an organizational capability to support it. I think we're all sold on the value of analytics and data science now. And we're at this point of moving from science experiments to making this a repeatable capability so that it's not isolated to one department or one problem, and turn it into something that's not a craft that's carried out by a handful of people tinkering. And that doesn't scale when you try to do it that way. When you try to hire people to solve the problem and you want more of that capability, you just hire more of those people, because today everybody in the market is competing for these people. And what we really need to work out is which parts of that process can we support with infrastructure? Can we support in the IT department? Can we support in the business departments that make it more repeatable, make it more effective, that get the best use of people's time, especially the high value side of that, the analysts, the data scientists. The question then is, how do you do this? How do you build the infrastructure to support them? And that's really something where you have to start by looking at what we have today and where we came from and what these new things require. So if we look at where we are today, we're really in the BI market. That's been 30 years of our history. We've been doing this for a very long time. We've been building data warehouses and data marts. We've been using BI tools. These things, they're stored in databases. They have schemas. We grab source data from a bunch of different places, some big, some small, and we feed that into this integrated data store. And we've been doing this for so long that we really have this pattern down. It's not something that we need to really think about anymore. We know how to do it. And it's geared towards one particular purpose, which is known data for known questions. If I know the question, then I know which information I need. If I know that, then I can go get that information, tie it all together in a nice little package, and put it in here. And then I access it. So the BI tools, all of this stuff, it's all about access. So your point of repeatability is the repeatable consumption of known quality shared data. The kind of information that you have to manage because everybody has to agree. What are inventory levels in a warehouse? Or what is the total sum of all orders today? Those things are juried and curated and of high quality because they have to be. And all you're really doing up here is accessing the information you need, which means that this is all built around an understanding of the core processes and aspects of the business. And that's what we've been doing for 30 years now, building for repeatable access of data. Today, the state of the practice, we call it a lot of things, but I would put just the generic label self-service onto this. We call it self-service BI, data discovery. What we've been doing is not that different from what we've been doing for a long time. You use something. In the olden times, it might have been Excel, it might have been an old ad hoc query product, now it's newer data discovery, data visualization tools. And you have a question, you grab the data that you need to answer that question, you put it into some form, say a workbook or something like that, or even a spreadsheet, and then you explore that data, you analyze that data, you figure out the answer to your question. The interesting thing is, why couldn't you do this over here? Because that's what this environment was for too. The answer is that this was for new questions. If you didn't know the question here, you're not going to be able to answer it here because the question guides the information content that you need and where you put it. And people have to agree on that stuff, so this is for the common information. And then along comes somebody who says, I've got this new problem, we're having out of stocks, we don't know why in the store, and so we need to do something. Where do I start? Well, maybe I need to get vendor information, and that's not in here. Maybe I need distribution information, and that's not in here. You don't know the question. If you're lucky, it's here. If you're not lucky, you have to go out and get it. And a new class of tools evolved to make that process easier, independent of this environment, so that the individual analyst could go and do the thing they needed to do. But it wasn't just unknown data. Sometimes it was the known data, and so it was just a different perspective on that. The real question here is, why isn't this information in here? We spent $1 million building this thing, and now somebody with a desktop tool goes out and grabs the information out of some operational system and gets the answer. So, is this thing broken? Well, no, it's just that that isn't here because of the time it takes. The time that it takes to do something like this varies from about 8 to 12 weeks. The industry standard, and it has been standard for at least 9 years now, is 10 and a half weeks. It takes 10 and a half weeks to go from, this is the information I need, where to find it, how to clean it up, what to put it into, to surface it so that an access tool, a BI tool, can go and get it. These questions tend to be of the ad hoc nature, or they tend to be new questions. Very often there's a crisis, there's a problem. In one company I worked at, we were having a lot of supply chain problems. And we worked out that it was vendor management, actually, that was the problem, and not our supply chain, and it was vendors being out of compliance and not giving us full truckloads of what we needed. We needed to solve that as quickly as possible. We didn't have the luxury of waiting around for 10 and a half weeks to do this process for the information. And it's always possible that that's a one-off question. Okay, this is what we need to do. We're done, we fix the problem, throw it away, move on to the next problem. So the time cycle here, the time cycle over here, they're different, and they're different by about 3x, possibly. That's a real big delta, and so you have to have this environment. You have to be able to do things independently of this, and then occasionally these things become really useful metrics, useful information, and when they do, you probably want to put them in this environment, because this is all about repeatability and everybody agreeing on the numbers. This is about getting quick answers to the questions. So you need both of these. Early on, we just didn't have any information, so this was sufficient, and now today, this is where we are. But it's independent of this most of the time. The real challenge is that typically it's a marriage of information that's coming from here with this. I need the actual real order counts and order value to marry with this other data to answer my question, which means that there's some integration between these two environments. But we don't build it that way. We build it as a silo. And then one day you come along with a question up here, and you end up with a different problem. And that problem is, it's probabilistic. You're not sure. It's not something with a nice, neat, even boundary on it. That might be a statistical question like, what's the earnings per share at the end of this quarter? It could be something like, what is the inventory on hand? And what's it going to be at the end of the week? And do I have enough in my warehouses to meet the demand in the stores that's out there? It might be something really complicated. So you've got maybe, what's the number of stores that I need in the Northeast to support the demand? Can I close stores? Do I need to open more stores? These types of questions, they're all different sizes, they're different shapes. Sometimes they're one-off. I worked on recommendation engines, doing upsells, cross-sells, recommending music, what song should you listen to next, that are ongoing. And so I've got different time scales. Well, this is all the world of data science or of analytics. And in this world, you have all these different questions driving different types of techniques. So for example, earnings per share forecast, I'm doing some statistical analysis. Maybe I've got some data that I'm going to work on for that isn't in the warehouse because I've never asked this question before. But it needs to be married with some stuff that's in here. And so I build out a nice table of numbers and I feed that into here. Maybe it's a complex question that involves machine learning. And so I'm using Python and I'm sitting on top of something called Spark, which is a way of doing high-scale mathematical analysis, basically, anything you can program. And that question uses other data and possibly this data and puts these things together, but it puts them together in a slightly different way and then feeds that in. And then maybe there's something out here that involves image recognition or pattern analysis and classification that uses some other sort of funky data. Or maybe it's exactly the same data as before. It's just structured differently to do this analysis. And what we've been doing is building these things out one at a time as these questions came up, as these analyses came up, as these questions drove different needs. And what we have now is chaos. We've got this chaotic environment, and we're working on this and trying to use these different tools. And so it takes a long time to get the right technique, figure it out, get the engine, find the data that I need, put it into the form that I need to support that specific analysis that I'm doing. And that could be something really quick. On the low end, it could be just like these problems over here. You do it in a week and you're done. It could be something that takes 6 months. So there's a lot more variability over here in this world than there is in either of these in terms of how long it takes because of the infrastructure and the questions. But what we're really looking at is 3 categories of question. Where we've been doing this for 30 years in the BI and data warehousing world. We started to add self-service and things got a little more complicated because now we're asking questions that haven't been asked before and we're managing them in separate environments. And then we started to add this and add more of this. And we said we need to do more and more of these things, but they're all one-off. It's like doing farm-to-table restaurants. I've got to go out and find the vegetables that are in season, pick those things, get them into the right preparation, and prepare this. And then tomorrow I do a totally different one, and then a different one again. And the problem with that is that it's not repeatable. And so you're taking your most expensive resource. Up here, the data scientist, the actual individual doing the work, that person spends all their time doing everything here. This was designed really for anyone. The whole point of BI was anybody could look at dashboards and reports. And over here, this was a little more technical, and we had analysts. And so what we have then is different user groups and different categories of questions being asked of different sets of information, which sometimes have to be linked. So we have a big picture of an environment, and the question then is, what do we need to do to support this? How do we make this repeatable? What we want to get to is making these people, and really any of these people, more productive by solving some of these problems so that you're not going soup to nuts every single time. And the point of commonality is obviously not up here in the categories of problem because they are from very well-known, well-understood data to semi-understood data to I'm not sure what I need. They're using things like databases here and self-service tools over here and multiple different kinds of engines over here. And so there's a lot of variability and it's necessary. The point of commonality is really all around the data that we're using. With this market, things are changing on a yearly cycle. New things crop up that didn't exist 2 years ago, like TensorFlow. We were really still experimenting with deep learning, and now suddenly we've got things that you can go out and call as a service. And that leads to all of this complexity, and you have to build to make this easy to partition out and change and throw away and add something new. But you also have to support the things you were doing before. This is not a world of build it all in one place. The data warehouse tried that. We tried to add analytics into the database. That didn't really work. We were trying to build a Death Star. And then the rebellion came along with this stuff and blew up the Death Star. If you say something like data lake, which is what a lot of us hear in the market these days, that solves this. That says, let's get all the information and put it into one place. Except that it doesn't really put it into one place. And these were in databases. Now we need to pull it out of the databases. This might have been stored in the cloud in S3. This could be in a cluster in your data center in Hadoop. And you're saying, build this in order to do things. Well, that's great, except that it only solves a small piece of the problem, which is the data collection problem. And it's unrealistic to believe that you're going to get all of the information into this because you don't know exactly which information you need at points in time. And so you have to be agile at collecting that stuff up. When you do that, and you say, I've solved this, I'm going to do this in self-service tools, now you're making every single person in the organization go out and pick their own food and cook their own meals. It doesn't work. If you're doing technology and you're trying to solve this, and you're trying to solve it in one engine, you're trying to shoehorn analytics into an engine that doesn't solve it. So when we start talking about things like data lakes to solve this big problem, we're not solving the rest of the problem. We're solving pieces of it. And then you want to do these various types of analyses, and each one is a one-off. And maybe you're trying to do deep learning image recognition, and you're doing some sort of AI thing. Well, you could do that over here, but it's not really ideal. And this environment is great for machine learning problems, but it's not really great for the statistical analysis you want to do. The tools are more productive over here. So you have different tools for different jobs, in the same way that you have different tools for different jobs in your home toolbox. When you lead with the technology and you say, we're going to go all cloud, or we're going to do everything shoehorned into the database, you're saying, I have a big hammer. I'm going to get a bigger hammer, and then all my problems will be solved. You're building a house, you need different materials than if you're building a skyscraper. And if you start with the tool and you say, well, I have an arc welder, so I'm going to use steel girders to build my doghouse, that's not really going to work. You're also collapsing things and trying to build a Death Star again, and the rebellion's just going to come along and blow up your nice, shiny new Death Star. So you have to think about discrete categories of problem and supporting these things. And that means, number one, focusing on the data. So thinking about this as one piece of the problem and recognizing that there's an intermediate step in here. That just because you've collected up all the information doesn't mean that you positioned it for the kind of use that it needed, or you provisioned people the things that they need. And you have to recognize that there are going to be multiple engines. It's great that you're using Hadoop, but that's not really a component of Hadoop, and databases are not what that was all about. That environment was for data processing and data collection, but it wasn't really for high numbers of users, it wasn't for quick latency and turnaround on questions. And so you need multiple engines, multiple platforms in the environment. That's an architecture problem. That's a big pattern. We go from the past, the present, and really the future of what we're looking at, and we have to think, what is the point of repeatability? Well, the point of repeatability is really at the data layers, both here and here, because those are the areas that when you throw out the technology and bring in some new technology, that piece persists, where this piece might not. We might decide that this was a terrible idea, or this was a terrible idea, and go back to doing something else. And the moment you say, well, I'm getting rid of this box, and I'm not going to do this anymore because it wasn't worth it, then you've got to swap that out. And if you built everything like this, you're throwing out a piece of your data environment, a piece of your server environment. You don't want to do that. So what we have to think about is the architecture, the overall pattern of what we're trying to support. And that's really driven by the people and the questions that are being asked. And what kind of question guides where that work should be done. The answer is not just a database, it's not just a Hadoop cluster, it's not the cloud, it's not a desktop. It's all of those things depending on the question and the need. One of the dirty secrets of data science is that 80% of the time it's done on laptops. You spent all this time building a high-scale compute cluster to do all this work in the cloud, only to discover that the analytic data sets on average are 10 gigabytes, and you're doing them on a laptop. The assembly of that data and the huge volume of data that was stored out there might not be 10 gigabytes, but what you actually do is, and so you need to separate these things. You can't plan on using this for everything when the work is done on a laptop. That means you've got to move the data around, and you've got to figure out which data sets you need for what purposes. So if you really look at that picture, workloads are key. What questions am I asking? What volume of data, what kind of things is the analyst working on that guides your technology choice? So that you can say, I need an arc welder because I'm building something that involves steel girders, or I just need a hammer to nail some boards together. That's what we're really after in building the infrastructure. That means that you've got a whole bunch of different uses out here. You need to focus on the ones that are important to you. Technology-led solutions like build giant data platforms gets you into trying to boil the ocean to solve all problems, but you can't. So you end up with questions guiding the technology choices, questions determining the workload. The workload, it's a database workload, it's a statistical processing or a linear algebra workload. It's just an ad hoc query workload that then guides what the back end of this thing. So at the end, the question is, what do? You understand the situation, but how do you go from this to building what you need, to building that organizational capability? Well, there's really 3 steps to an answer. Number 1 is to recognize that this is probably a familiar mess. Everybody's got things like this, pockets of self-service, data warehouse, multiple data warehouses. You've got analytic silos, you've got departments doing things, you've got people with laptops, you potentially have big teams working on huge infrastructure, but they're all doing their thing independently of one another. And it was that way because you took the narrow perspective, each person solving their small piece of the puzzle. So now you recognize that there's a bigger picture, and you have to map this out for yourself. What things do I have? What things am I doing? And where am I doing them? And for whom? The next step of this is once you've recognized this problem and you've identified the things that you're doing and whether you're doing them well or not, and worked out some of the overlaps, then you can look at what kinds of questions am I asking? What kinds of problems am I solving? What's the value of those problems? What's the technical constraints around that? And we're really talking about architecture. The questions, the problems you're trying to solve with the value attached, that's why we're doing this. Architecture is the patterns, it's the pictures, it's how we arrange the pieces. Maybe for you, it's a Spark cluster and Python programmers and data scientists on a cloud environment, but for me, it's 16 people with laptops pointed to a database. Every organization is different and has different needs. And that's really why you can't cookie cutter these things. So your 3rd step is to really step back and look at this picture, look at all the different components of it, starting with the questions and prioritizing and understanding those questions, because you can't just do it all at once. Half of this you've already built out in different ways. You have to step back and rationalize that in a bigger picture, and that's what architecture is. The questions, the uses, they tell you why you're doing things. The architecture tells you all the different pieces and what you need to support answering those things and managing what's behind it. The engineering, the technical choices, pick a database, pick a Spark cluster, use S3, use AWS services. Those technical questions have to be guided by that. And that part, that's the engineering. That tells you how to do it. So you have your why, you have your what, and you have your how. And you put those 3 things together in sequence. That is the full picture, and that's what you need to work on.